All right, welcome back. So for this problem, we initially drop a rock off of a cliff. So here's my cliff, and here I am. Here's the rock, and I drop it off of the cliff, and when it hits the water, the sound goes back up, right? And when I hear the sound, it is 2.7 seconds after I drop it. All right, so we want to find out how high is this cliff based off of the fact that it took 2.7 seconds for the sound of the splash to reach my ears after having dropped it. So we've got kind of two steps to this, or two components here. We've got the fact that it takes time for the rock to fall to the water, and it takes time for the sound to go from the water back up to my ear. So, well, let's take a look at this. The equation for an object falling, right? We've got in free fall, so we're assuming no other forces acting on the rock here. So it's the position is given by half the acceleration, which in this case is gravity, half gt squared. All right, we'll call this t1 since it's the time it takes for the rock to fall to the bottom. And then that would make this distance right here x. All right, well, we've got that equation right there. Really, we have two unknowns since we don't know how long it took for the rock to fall. We only know how long it took for the rock to fall and the sound to come back up. So we've got our second equation here, which the sound travels the same distance and it travels at the speed of sound, which we'll call v, and it travels for a time t2. We know that the total time it took, so t sub t, is equal to t1 plus t2. All right, so we can start working through this a little bit. We can set these two equations equal to each other, right? This one and this one right here, since x is equal to x, right? So we've got half gt1 squared is equal to vt2. And then using this equation right here, we can solve for t2. So we're going to say that t2 is equal to t total minus t1. All right, and then we can plug that into our equation. And distribute the v Oops, I almost didn't distribute it there. That would have been bad. All right. Sorry, this should be a t total right here. All right. Now we can put everything to one side and solve for, we only have one variable here. It's t1, one unknown variable. So let's do that. Half gt1 squared plus vt1 minus v t total is equal to 0. Move this down a little bit. All right, so this looks like a job for the quadratic equation. Hopefully you can see that. We've got a squared term, a linear term, and a constant term. All right, so we've got 2 times half g, right? So I'll just simplify that already and say it's just g here in the denominator. We're going to have minus v, and then I know in the quadratic equation it's a plus or minus, but since this right here is already a negative, we know that this is going to be a plus sign because otherwise we would be getting a negative time, and that does not make sense in the context of our problem. So, oops. All right. And then v squared minus 4 half g negative v. All right, and if you plug in all the values into this equation, so I used 343 meters per second for v, 9.8 meters per second squared for g, and I guess that's all you need. You'll find that T1 is equal to 2.603 seconds. All right, so we're not quite done. This is how long it takes for the rock to fall this distance right here. So we can plug that back into our original equation and watch what happens. This is amazing. All right, so we've got x half g, which I'll just plug that right in, 9.8 meters per second, and T1, which is 2.603 seconds squared. And plug that into your calculator, and you'll find that x is equal to 33.2 meters. And boom, there you have it. That is your final answer.